This is Mr. Hardesty. In our next problem, we'll use special factoring techniques to simplify. Factor each polynomial. X squared plus 24x plus 144. In this polynomial, we recognize that the first term is a perfect square and the last term is a perfect square. We think foiling in reverse. FOIL, when we multiply binomials, we know stands for first, outer, inner, and last when we multiply. If we think we will FOIL in reverse, I know that the first two terms would have to be x and x, for x times x is x squared, and that's a perfect square. At the other end, L for last times last, we recognize that 144 is a perfect square. That is, 12 times 12 is 144. Now we consider outer and inner. When we do the outer product and we get 12x, and the inner product is also 12x, we know that their sum is 24x, which is our middle term. That means we need a positive 12 and a positive 12. So we've factored our polynomial as x plus 12 times x plus 12. That could also be expressed as x plus 12 squared. 32a to the fourth minus 50y to the sixth. We recognize in this example that 32 and 50 have a greatest common factor of 2. So we'll factor out 2, and we're left with 16a to the fourth minus 25y to the sixth. Now we recognize our binomial as the difference of two perfect squares. That is, it can be written in the form a squared minus b squared. And we know by this factoring technique that we'll factor the difference of squares as a minus b times a plus b. In other words, since we have two perfect squares, we can take the square root of each. The square root of 16a to the fourth is 4a squared. That will represent a times a in our difference of squares template. And for b, we have the square root of 25y to the sixth, which is 5y cubed. 5y cubed times 5y cubed is 25y to the sixth. We need one sign of each, minus and plus, and then don't forget the 2 that we factored out to begin with. So the factored form of our binomial is 2 times the quantity 4a squared minus 5y cubed times 4a squared plus 5y cubed.